everyone, good day, pre-algebra. We are continuing on our probability unit with calculating probability of a single event. And I need to resize in case the opportunity for a button presents itself. We've got to be prepared. Okay, what is the definition of probability? We've already defined this. We defined it in PO39. But we're going to do it again because the more that you look at something, read something, write something, the more you remember it. Ryan.
The likelihood of an event happening.
The likelihood of an event happening. That seems different. Let's see. Got that. Okay. Okay. All right. We'll just. Okay. The likelihood of an event happening. Okay. The likelihood of an event happening. We talked about the scale of probability. Who can remind us what the scale of probability is all about? What's the lowest probability you could have? What's the highest probability you can have?
0% to 100%.
Yes, 0% to 100%, right? You cannot go below 0. There's no negative chance of something happening. I mean, if it absolutely will not, guarantee to not happen, 0%. There are very few things in life that have a 0% chance of happening, but it's out there. And then if it's absolutely guaranteed to happen, no question, then it's 100%. Okay, there are also very few things in life that have 100% chance of happening, right? But it's out there. Everything else falls in between those two values. We talked about 50%. 50% would be just as likely to happen as not happen, okay? Flipping a coin would be the classic 50% example. In between 0 and 50, we also mark 25%. And anything kind of around this percentage is considered not likely to happen, 15%, 20%, 33%, not very likely to happen. Whereas on the other side of 50, 75%, we would say that would be likely to happen. Not guaranteed, but likely to happen. Okay? And now for the probability formula. Anyone think back to last year? How do you actually calculate probability? Okay? How do you actually calculate the probability, the percent chance that something is going to happen? Okay, well, here we go. We're all going to learn something new then. So the probability formula, we're going to write it a couple different ways here. Okay, but essentially it's what you want to happen. What you want to happen divided by what could happen. Okay? What you want to happen divided by what could happen. Another way to define or write that very same definition would be successful outcomes. This one's a little bit shorter. Successful outcomes divided by possible outcomes. Okay, successful outcomes divided by possible outcomes. And who recognizes that phrase possible outcomes from something we've done before? Mia? Perhaps phrased in the question, how many possible outcomes exist? Where have we worked with possible outcomes before? Starts with a C, ends in counting principle. Counting principle, well done! Okay, counting principle. We spent PO39 essentially learning how to calculate this, right? The possible number of outcomes, if it's not given to you, we can calculate it using the counting principle. That's why that was a PO. Turns out it's pretty important to help us with probability in general, which is PO40 here. Okay, so today we're going to be focusing on this formula. What are the successful outcomes? How many possible outcomes are there? And then calculating the percentage that something is likely to happen. Okay? Questions so far? All right, let's go. Calculate the probability of each event written as both a fraction and a percentage. Okay? Because percentages are their cousins with fractions and decimals. You know, we've converted these before. I want them in both forms. Decide if the event is likely or not likely, and you need to show your work. So here's the situation. You have a bag of 60 marbles. 9 are red, 24 are blue, 15 are white, and 12 are yellow. And the first question is, what is the probability of choosing a red marble? Okay. Now I've written it out in word form here. If you see a probability question on your math test, it's probably going to look something like that, P parentheses red, right? That's like the probability notation. So just be aware of that if you ever see it. Capital P and something in parentheses, that's the probability of whatever you want to happen, right? So our formula, I'm going to write it out again. Successful outcomes over possible outcomes. Okay? If we want to choose a red marble, that means choosing a red marble is successful. How many successful outcomes are there? Or, nobody think about that, how many red marbles are there? Gregory? 9. Tells you. Okay? So the number of successful outcomes is 9. How many possible outcomes are there? How many marbles could we pick? 60, right? We could pick any of the 60. So the probability of choosing a red one is 9 out of 60. There's our fraction. Cool. Okay? Now how would you convert that to a percentage? Because you need to write it as both a fraction and a percentage. What could you do? Anthony?
I would say we could divide 9 by 60.
Yes, you can go to your calculator, and one option is to take 9 divided by 60, because a fraction is just division. And what decimal do you get?
0.15.
0.15. Now that's not a percentage.
Oh, 15%.
Exactly, right? 0.15, which equals 15%. There is your percentage. Okay. The other option would be to set this up in our part over whole equals percent over 100 formula, right? 9 over 60 equals what over 100, and you can use cross products to solve that, and would equal 15% here as well. Probably easiest to use the calculator, okay? But the proportion formula does work just as well. So is this likely or not likely to happen? Pick a red marble. Not likely. 15% would be only 15 out of 100 times, right? Remember the word percent means out of 100. So if you did this 100 times, you're likely to pick a red marble only 15 out of 100. That's not very likely to happen. Right. Initial questions. Does this bring back fond memories from sixth grade year?
I don't remember.
Don't remember doing this. Did you do this last year?
Maybe.
Maybe? Good. All right. Well, we will carry on. What is the probability of choosing a yellow marble? Which, again, if you were to see this on a math test, it would be P yellow. Just means the probability of what you want to happen. This is how the con uses it too. So I'll probably assign some probability con. Oh, there's no con due this coming Thursday. I completely forgot to assign it. So I'm not going to do it now and have it due Thursday. So I have a week off. But when I assign con for next Thursday, I'll throw some probability, and con likes to put it in this form here. So just so you are aware of that. Successful outcomes and possible outcomes will abbreviate SO and PO. How many successful outcomes are there for picking a yellow marble? Nolan? 12. 12 yellows. How many possible outcomes are there? Null again.
60.
Still 60, right? That part doesn't change, okay? There are still 60 marbles in the bag, whether we want to pick a red one or a yellow one or a blue one or whatever. What is, so there's your fraction, right? And what is that as a percentage? Peyton.
0.2 or 2%.
Okay, so when you divide this in your calculator, 12 divided by 60, you get 0.2. And what percentage is that?
20%.
20%, right? 20%. Okay, 0.20, which equals 20%. 2% would be 0.02. Okay, but 0.20, 20%. Likely or not likely to happen?
Not like
Not so likely to happen. All right. Questions? If probability is new to you, then hopefully, this is kind of making some sense. If it is a review, it's okay too, but please ask questions if you have them. Do the next two, actually, no, let's do the next one. What is the probability of choosing a blue or white marble? So this word or connects these two things together, right? So when you look at your successful outcomes over your possible outcomes, how many blue or white marbles are there? Both of them would be considered successful. 39. Did you add 24 and 15?
Yeah.
Okay. So 24 blue plus 15 white, right, equals 39 total successful outcomes out of 60. There's still 60 marbles in the bag. There's your fraction. What is that as a percentage?
65.
And how'd you get that?
39 divided by 6.
Did you get 0.65?
Yeah.
Okay. If you ever don't get a perfectly well-rounded decimal, just round to nearest hundred. Like if this was 0.65, 1872, whatever, just round nearest hundred. Okay? 65% chance. Likely or not likely to happen?
Likely.
Likely to happen. Not guaranteed, certainly, but likely to happen. 65% of the time, 65 out of 100 times, you would pick a blue or a white one. Do the last one on your own, red, white, or yellow, right? So you've got kind of three of them that are all grouped together there. Give it a shot. Write your answer as a fraction and a percentage. And raise your hand if you are confident in your solution.
He's crossing the force field.
Force field is stronger than ever. Thou shalt not pass. Some confident folks. Okay, Josie, what you come up with?
I got 60%.
And how many red, white, or yellow marbles are there?
36.
36. Do we have a second on? I can't see how many there are in the bag. Well, there were 9 red. How many were white? 15. And how many were yellow?
12.
12, 36. Good. So successful outcomes over possible outcomes. 36 are successful. 9 plus 15 plus 12. There's still 60 marbles in the bag. There's your fraction. 36 divided by 60 gives you 0.6, which of course to the nearest hundredth, right? 0.60 or 60% chance. Likely or not likely to happen?
Likely.
Likely. Okay, a little bit better than a 50-50 chance. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Okay, looking at the second page. Any of these that look like they might be worth our time? Calculate the probability of each event, both as a fraction and a percentage. Show your word. We've got letters of the alphabet, the probability of choosing a vowel, the probability of choosing a consonant. Every year I get questions, what is a consonant?
Any number, letter that's not a vowel, right?
Yes, any number, any letter that is not a vowel, right? So if it's not a vowel, A, E, I, O, or U, that it is a constant. What is the probability of choosing a letter A through N or S through Z? That word "or" connects them, right? And then finally, what is the probability of choosing any letter in the phrase SVDP Royals? Then we are flipping a coin 5 times. What is the probability of getting all 5 heads? What is the probability of getting 4 heads and a tail in that order? What is the probability of getting 3 heads and 2 tails in that order? And a couple more questions to do that. Let's talk about this one here. Okay, flipping a coin 5 times. This brings back the counting principle from PO39 here, because we've got to figure out not only how many successful outcomes there are, but possible outcomes too. Okay? How many possible outcomes are there from flipping a coin 5 times? This is the situation here, right? How many possible outcomes exist from flipping a coin 5 times? Yeah. No. Total outcomes.
Yeah.
Like your first flip, right? On flip number 1, there are 2 outcomes. Yes. But how many total outcomes are there for all 5 flips? Read again. More than 10. Flip 2 will be another 2 outcomes. Flip 3 is heads or tails, so another 2 outcomes. Flip 4, another 2 outcomes. Flip 5, another 2 outcomes. I can see how you get 10, but remember, what does the counting principle tell us we need to do with all those 2s? Gregory?
It's 32.
We
have to multiply.
multiply them. Okay, we multiply them. 2 times 2 times 2 times 2 times 2. There are 32 total outcomes from flipping a coin 5 times. Okay, 32 total. So our denominator here of this fraction is going to be 32. Now, how many of those outcomes would get you all 5 heads? Of those 32 outcomes, how many would be H, 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 H? Gregory, is the hand up or no?
5.
I mean, you could get, H, 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 H. You could get H, 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 T. You could get H, 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 T, H, right? We're not going to write out all 32 outcomes. That take quite a while. But if we were to, how many of those outcomes would have all 5 H's? That'd be half of them, right?
Would it be 1?
Just 1. Okay, there's only 1 outcome involving getting 5 heads, and that's up the board. H, 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 H. Okay, of those 32 outcomes, only 1 of them involves getting all 5 heads. Not very likely to happen, is it? What is that as a percentage? Here's your fraction, 1 over 32. What is that as a percentage? Anthony.
3.
And what's the actual decimal that you come up with?
I silly delete. It's 0.03125.
Okay. 1 divided by 32 is 0.03125. Here's an example where that decimal doesn't work out perfectly, so we round it, okay, to the nearest 100%, being out of 100, right? So 0.03 is what this would round to the nearest 100th, and that is 3%. You have a 3% chance of getting all 5 heads. Is that very likely to happen? Not at all. Okay. If you were to do that 100 times, you would get projected to get all 5 heads 3 out of those 100 times is what that would mean. The next one, what is the probability of getting 4 heads and 1 tail in that order? So again here, going to our successful outcomes over possible outcomes formula, did our number of possible outcomes change? If we flip a coin 5 times, is there still going to be 32 possible outcomes? Yeah, right? Just because we want something different doesn't mean that what could happen changes. Okay? There are still 32 possible outcomes from flipping a coin 5 times. But now the probability of getting 4 heads and a tail in that order means that we want specifically a head, a head, a head, a head, and a tail. Right? In that order, we want 4 heads and a tail. How many of those 32 outcomes would come up head, 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 tail? Just 1, right? That specific outcome. So again, we're looking at a 1 out of 32 probability. Okay? The next one. What is the probability of it getting, and so obviously our percentage would be the same here, right? 3%. It's the same fraction as it was above, could be the same percentage. What is the probability of it getting 3 heads and 2 tails in that order? Well, we're looking for specifically head, 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 tail, tail. We want it in that specific order. How many of our 32 outcomes will be a head, a head, a head, a tail, tail?
1.
Just 1 again, right? We're gonna this phrase in that order turns out to be pretty important. Okay? It changes how we think about things. Would our percentage be different if we could get 3 heads and 2 tails in any order?
Yes.
Yes. Right? Because getting 3 heads and 2 tails in any order means we could get head, tail, head, tail, head. Right? Still 3 heads and 2 tails, but getting it in this specific order leaves us only 1 possible outcome. So I think there's a question down at the end that says in any order. Okay? Be thinking about that. All right, but I'm going to let you do the rest on your own. Okay? Any final questions? Any of the ones from up above you want to go over, talk about? Nolan?
How much vowels are there?
There are 5. If you want to include the 6th, because sometimes Y, that's okay, but there are traditionally 5. A, E, I, O, and U. Anything else? Make sure you are writing your answer as a fraction and a percentage. Okay? Both of them for credit tomorrow. And we will have a homework check on this tomorrow. Anything else? Okay, PO40 homework for tomorrow. You got 6 minutes left to work. That's how you math.
Don't forget to like